Alright, this is section 10.2, arcs and measures. I'm just going to dive right on into it. An arc is a part of a circumference. A part of the circumference. And basically, I'll go a little bit more into detail through this notes here, but basically this right here is an arc, and what we're going to be doing is finding the measures of arcs in this section. So a minor arc has two endpoints right here. This is how you name it. You name a minor arc with two endpoints. And then for a major or semicircle arc, you name it with three. Sorry, I have to go back here. There we go. Name with three endpoints. Or I should say three letters. And two of the endpoints will be the same as your minor arc. And I'll explain that a little more whenever I get to that. So this first arc here, from A to B, we're going to call this our minor arc. You should note that a minor arc is always going to be less than 180 degrees, because if you think about it, a semicircle will measure 180 degrees. And let me rewind a little bit more in case you don't know that to measure around a whole circle, it takes 360 degrees to go around a whole circle once. There's actually two ways to measure a length of a circle. It's with degrees or radians. Radians aren't going to come into play until pre-cal, so you don't have to worry about that just yet. So whenever we label this minor arc right here, we're going to call that AB, and the symbol that y'all are going to be introduced to is this right there. That's how you denote it as an arc. Okay, and then the next one here, we're going to call it a semicircle. And that is basically, semicircle. And you would name that by saying B, A, D. Okay. And for a semicircle, the endpoints are points that consist of the diameter. Sorry, I kind of ran off the page there. So the semicircle contains D and B. If you were to draw a line through that right here, this line segment would be the diameter. So the diameter, remember from our last section, goes through the center of the circle, and the endpoints of the diameter is what's going to start whenever you're naming your semicircle, and it's going to end. And then this middle is a point that lies in between these two endpoints. Alright, if I didn't confuse you yet, the next one is going to be a major arc. And so a major arc goes from one endpoint of the minor arc to the other endpoint of the minor arc. So from A, or from B all the way to A, or A all the way to B. And we would denote that as A, D, B. This arc encompasses D, so D is going to be our middle letter here. So it's going to be A, D, B. Let me pencil that in so you can see that. This is a D. Okay. Now, the next thing you need to know is this angle right here. This is known as the central angle of the circle. Okay, and that would be called angle ACB. And then that would be angle ACB. Okay, and what we're going to find out is that the measure of our central angle is the same as the measure of the arc of our minor. Okay, so I'm going to move this up. And so now this is what this section is going to be mostly about, is solving for arcs. So if we are, let me write down the formulas that you're going to need to know. So if you have a minor arc, the minor arc is equal to the central angle, and then a major arc is equal to, if you think about it, it's 360 degrees for this whole circle, and then if you want to know from here all the way to here the measure of this major arc, then you're going to have to subtract 360 by your minor arc. Okay, so the formula to find the degree of a major arc, you're going to do 360 minus by the measure, I'm just going to do M for measure of AB. And I'm referring to AB as our minor right here. So the major arc equals 360 minus by the measure of your minor arc. Okay, so for this problem here, if we wanted to find the measure of the minor arc AB, we just learned that the minor arc equals the central angle. Well, from our vocabulary, we know that 60 is our central angle in this circle. So this one's pretty straightforward. We're just going to call it 60 degrees for our arc right here. Okay, and if we wanted to write that out, we would do angle ACB, the measure of angle ACB. Got to make sure you put that measure there. Measure of ACB equals the measure of AB. Now you notice my M here is not right there, and that's because I wasn't finding the measure of this arc, whereas down here I was finding the measure of the arc, so I have to put the M here for measure. So the measure of arc AB is equal to the measure of angle ACB. Alright, now for our major, we know that it's the 360 minus by the minor, and so we do 360 minus by the measure of AB, arc AB, and we get that 360 minus by 60 equals 300. So the measure of degrees from endpoints A to B, so from endpoint A to B, this right here is a total measure of 300 degrees. Alright, we're going to keep it moving here. Alright, the arc adjacent postulate is not one that you have to have memorized, but you do have to know how to solve for it. The definition states it's the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Okay, the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Okay, when you read that, you're like, what is that saying? Okay, so let me show you. So you have arc AB, and then you have arc BC, okay, and then this postulate is telling us that the measure of arc AB plus the measure of arc BC is equal to the measure of arc A, B, C. So A, B, C. Sorry, I'm kind of running off the page here. Let me zoom out a little bit. Okay. Alright, so we're given that measure of arc AB equals 45 degrees, so this is 45 degrees, and then measure arc BC is equal to 152, so this is 152 degrees. So if we add these two together, we're going to get this whole arc right here. Okay, so this whole arc is going to be 45 plus 152 degrees, which is going to equal 197 degrees. And then there's two more vocab words that I would like for you to know for this section. The first is that congruent circles are circles that have the same radius. Okay, and then congruent arcs is if a circle have the same measure, then they are arcs of the same or congruent circles. So let me write that out for you. If circles have the same measure, and their arcs of the same, or if the arcs are the same or congruent, circles. If circles have the same measure and their arcs have the same measure and their arcs are the same or congruent, then you have congruent arcs. Okay, now that's a wrap for this section. If you have any questions, come to class and have a good day. Thank you.